This is Mr. McGovern. This is the second video in the wave series. We're going to look specifically at sound waves. So sound waves, you can see from this diagram from the speaker here, they have to travel through air, and they're really just a compression of air. And you can see with the diagram here, the compression and the spreading out of air means that the sound wave is a longitudinal wave. Now, despite it being a longitudinal wave, we actually just treat it in physics problems as a transverse wave. The reason we can do that is it's kind of mathematically equivalent. We can, simply line up peaks with peaks and peaks with compressions and rarefactions with troughs, and it just makes life easier. It makes life easier for diagrams. It makes life easier for adding waves together if we need to add waves together, and to do calculations with as well. So even though sound is a longitudinal wave, we often draw it and model it as a transverse sine wave. So sound, because it goes through air, or through molecules, can go through atoms when they're a solid, can go through atoms when they're liquid, can go through atoms when they are as a gas as well. And because those atoms in a gas versus a solid are different distances apart and moving at different speeds, interacting differently, you get different speeds. So sound has different speeds depending on the material it's going through. So for example, the velocity of sound going through room temperature air is 345, 346 meters a second. Whereas sound going through 0 degree freezing temperature, air still is much slower, 330 meters per second. So even going through air at different temperatures gives you a different speed for sound. Going through water, sound travels much, much faster because the atoms are much, much closer together. It goes through 1400 meters per second. So in any questions you'll be asked, in any assessment you do, either you have to calculate the sound speed given a bunch of information, or more normally they will give you the sound speed of sound for whatever situation they're asking you to comprehend. Humans can hear sound, obviously, you're listening to me as I speak, but they can hear a range of sound, and the range we can hear is from 20 to 20,000 hertz, that's the frequencies. That doesn't mean that sound can't exist outside that. Sound can be a lower frequency than 20 hertz and a higher frequency than 20,000 hertz. It still exists, we just can't hear it. Other animals certainly can, and the machines that we build, the detectors we build to measure sound certainly can as well, but that's our limit. In fact, the 20,000 hertz as well gets less and less as you get older and older.